Welcome to the second industry session in IESMA 2018. Today, we will hear from our 7 silver sponsoring companies that operate in the areas of software development, defense electronics, industrial automation, container industry, power management, illumination and lighting, and much more. Please welcome on stage our first presenter from the Estonian company Datel, who are specialized in contactless critical energy infrastructure monitoring. Ma'am, the floor is yours.
Afternoon, everybody. And thank you for joining us today to our amazing discussion about energy resilience using spacecraft. So you can see on our screen is our spaceship. That's where we're collecting data from. Fortunately, there are 2 of them. We have twins. We are able to determine the motion of any structure or surface on Earth, 1 millimeter at a time, every 6 days, with our spaceships that you're seeing here. The white panels that you're seeing above are called radar array. That provides us the data. Currently, our twins are roughly positioned at 30-degree angles to the planet. Because our twins are roughly positioned, we're able to build 3D models of reflectivity of anything. This allows us in 3D space the ability to measure the motion and structure of any structure, be it a hydrolytic dam down to a small diesel generator located on Ford operating base in the middle of any desert. So we have a lot of cool things to talk about today, so let's get started. Is that working? There we go. So we know often that defense technology can be presented in not, oops, start it again. Let's go. So we know that often defense technology can be presented in not such an exciting fashion. So I decided to jazz it up a little bit and just go big and splash about our story, because we have a really cool story to talk about, because one of the coolest things about what we're representing today is our alliance-wide effort. What I mean is our technology was developed in Estonia using the European Space Agency satellites, where we have open access gov data that we post-process. We have deployed in the Azores, and that's where my company that I work for called ICON is based. But I work in the United States and I live in New York. So we have a really nice frontier-to-frontier approach. So today, I'm going to go over a few topics: civilian INSAR technique, which is radar processing technique, how we combine SAT data with web technology, some keys in energy resilience, and what's next for us that we think we can do together with people like yourselves, whether it be government, military, or private sector. So PINSAR, it's a big crazy acronym which is really familiar in the military world. It's Persistent Scatter Interferometric Synthetic Aperture Radar, which means we have persistently scattering the data radar image. It has been the same forever, extremely accurate down to the millimeter level. Interferometric means we apply physics and are able to provide the ground motion of any object, and our DoD uses this anywhere all over the world to determine where a target is located in deep, thick foliage, extreme weather conditions, and dense cloud coverage. It's been accessed since the 70s. Inside the black and white boxes, up here, is what we use. Interferometric means we apply physics and we're able to measure the ground foliage. And so in the boxes, we have phase data. So phase data gives you the motion of the object, and it takes for a long time for technology to be able to deliver this type of access of motion data. So we're really excited to be able to apply that. And there are a lot of satellites out there that do a lot of similar things. You have the TerraSAR X, which is operated by Airbus. It's the ALOS system is a NASA satellite, and the Sentinel is the one we work on. All satellites are quite different. ALOS is a really slow orbiting satellite, and will only have 6 orbits, which prevents us from getting a real level of accuracy of data. TerraSAR X is geosynchronous, super task-driven, and it's super expensive to run. And one of the shortcomings of that satellite for us is that its inability to give us global history from everything on the planet. The Sentinel-1, which we have our twins, has been up in orbit for over 2.5 years, so we have really good global coverage of the entire planet in motion at the millimeter level. We achieve mileage at the millimeter level, which is great, helpful for our accuracy. So another big access that we have up here are our ground reflectors. We use them. These are triangular objects that we can see at the top of the screen that I just pointed to, and we use them for a reason to really pinpoint the focus of something that we want to monitor specifically. The Copernicus CapForm that I talk about here, this is really all that makes it possible for us and affordable, because we have the access, the raw data is free from the European Space Agency, and we just post-process it. So what does this mean to us? It means that the data is accessible and affordable to any military anywhere in the country, like Georgia or even the United States, where we don't have unlimited defense assets. And it's good for us and other programs to have access to this data so we don't task up our stuff. So we have developed a web application that you can display our information anywhere on any smartphone, any desktop. And it's a really light, it doesn't have a lot of bandwidth, so you can load it up via satellite NROD connection in the field at your desktop. It has a contact list application, so you can determine any information anywhere at any time. What you're witnessing here is a bridge in Miami that is unfortunately in really bad condition. So any type of information that we give that's easily accessible to people really can help you, even if you're in home, an alliance, or you're abroad fronts. And we can get this data into your hands and for a fast, accurate decision-making process. So energy resilience starts with the situational awareness and really understanding what is going on. To me, that's a really big deal, and to others, I'm sure you feel the same way. The picture that you're seeing here is a port of St. Lucie, which is in really bad, under-resourced country and doesn't have unlimited ability to understand what's going on there. As you know, the U.S. Navy deployed to Haiti on humanitarian efforts. When they got on the ground, they realized they didn't appreciate the true infrastructure capability of what's happening. If they'd had our information, we were able to access that data and really process what is the structural soundness of what they're looking at in approximately about a week to 10 days for them. So when we assess situation in a week, we're able to give them really what's failing and what they can focus their priorities on, which is a pretty big deal for the country, and it would be a pretty big deal anywhere, especially if you had oil facilities and gas lines right in front of your seawalls. If they were breaking down, this would compromise that situation. Slope civilizations, Basically, we have the ability to monitor slopes. Excuse me for 1 second. Example of a slope civilization use where we had a generator or a fab or something up there when you're placing diesel generators in the field. Understanding the stability of the ground before you deploy is of utmost interesting and important to you. Being able to monitor in real time is super critical, and you can add reflectors to the area to monitor them and reduce the maintenance and downtime problems, because we all know that logistics are a nightmare when having to need to repair those units. Oops. This is just another example. This actually is a slide out of Maryland where we're able to monitor slope sliding block techniques in real time. They were interested in understanding what's happening here for safety issues, so they asked us to monitor the areas for the roads to make sure that it remains in a safe environment. Just another example of how we pinpoint that data and we can access it to a grid to really show you in real time what's happening there. Again, here's a picture. This is an area of a mining casualty. We're able to monitor what's going on after a mining collapse, where you have the available information for critical decision making in real time. Global use of SILI. We are fortunate to have a lot of global use of SILI from Estonia to the United States and key agencies like FEMA, the big American chemical groups, Finland's nuclear power plants, and local and state gov. Where we're going next? We're getting to the point where we can display this data in some exciting ways. 3D, building footprint anywhere. We have the ability to place. We can do block level risk assessments for for FEMA and other countries. And I believe we have the ability to monitor key assets without using key resources. And that's what this is all about, this talk today. So we really look forward to you stop by our booth, and thank you very much. Any questions? I can't even see.
Thank you for a great presentation. Have you assessed or had experience in assessing stability of the landscape around nuclear power plants or objects like that?
Absolutely. So in Pennsylvania, there was a plant that was assessed, and we've noticed an 8-millimeter shift. And so before anything really happened, we alerted them of that because their cooling towers had shifted, but they were not able to visualize that, but we noticed it because we were asked to monitor that area. So what we brought to them is to their engineers' attention that something has changed, and that helped them to prevent an event. Thank you for the question. Anyone else? Thank you, everybody. Have a great afternoon.